In this video for section 8.1, we're going to talk about empirical and theoretical probability. We'll also be defining what those terms mean in this video, so if you don't know, don't worry about it right now. So what we're going to do is we're going to do an experiment, and that experiment is going to answer the question, what's the probability of getting an odd product from two dice? So if I roll two regular dice, regular six-sided with numbers 1 through 6, two regular dice, and I multiply the two numbers that come up, what is the probability that I get an odd number? Now you might guess that it's 50%, and that is a reasonable guess, so we'll see how that checks out as we go through here. So we're going to use this virtual dice roller. You can click on this link. Or if you have two dice at home, you can just roll physical dice. If you take them out of a game or something, that works just as well too. So when I go to the website, this is what it looks like. I can change the number of dice if you wanted to roll more dice, but we're just rolling 2 here. So that's going to stay as 2. Then I just click roll dice and it rolls them for me. So I got a 2 and a 6. So if I multiply those two numbers together, I get 12. And so that is an even number. So I'm going to record my results here, separated into odds and evens. So if I got 12, I would put that under even results, and then I would repeat the process, rolling 2 more dice. This time I got 3 and 3, which is going to be 9. So that's an odd number. So I'm going to put that under odd results. Now I've already done this, so I'm going to just put my results here. Just to save a little bit of time. So you're going to continue. You may want to pause the video and do this on your own. Collect your own data. You might get slightly different results. Obviously, your rolls are going to be different than what I have here. But that's okay. What you should end up noticing, though, is that you should get many more even numbers than you do odd numbers. So it seems like 50% is not going to be the correct probability for rolling an odd product. So I'm going to count to make sure I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 rolls. I want to have 20 rolls total just because that makes the math nice and easy. So how many times did you get an odd result? And then we want to write this as a fraction out of 20 and turn it into a percentage. So we got an odd result 4 times. Whoops. And writing it as a fraction out of 20, 4 out of 20, which is 1/5. Which is 20%. And this is called an empirical probability because it is based on the result of an actual experiment. So anytime that you're doing an experiment, you're collecting how many times something happens, and then you're counting how many times you did the experiment altogether. Divide those two numbers, you will get an empirical probability. So empirical, experiment, those two words go together. Now, in question 6, we're going to determine the true probability or the actual probability, which is also called the theoretical probability. So this is the probability that we calculate using math. So we can calculate this probability, the probability of rolling an odd product, without ever actually rolling dice, and that's what we're going to do next. So what we're going to do here is we're going to list all the possible products in this multiplication table, and this is called the sample space. So I'm just going to multiply the number in each row and column, and then the product goes in the that box. So 1 times 1, 1 times 2 goes here, 1 times 3 goes here, etc. And so we're going to be doing some nice multiplication fact practice here. You can do this at your own pace. If they don't come to you quite as quickly, that is totally fine. But I'm just filling in my products. Or you might be faster than I am, that's also fine. Okay. Okay, so these are all of the possible products. So there's no way for me to roll 2 dice. If they're regular 6-sided die, numbered 1 through 6, I can only get these numbers. I cannot get 50 or 100. The sample space is all possible results of rolling 2 die and multiplying the 2 numbers that show up. So we're going to use our table to find the probability of rolling an odd product. So looking at our table here, we're going to identify all of the products that are odd numbers. And I'm going to highlight them to make it easier to count. You can see that what happens is if, for example, if one of the numbers is 2, then all of the products are going to be even numbers. It's not possible to multiply a number by 2 and get an odd number. So I'm highlighting them all here, and as you can see, there are a total of 9 odd products that I could get when I'm rolling 2 die out of 36 total possibilities. So we have 6 times 6, 36 total possibilities. 9 of them are odd, so 9 out of 36, which is 0.25 or 1/4 or 25%. And you'll see on the homework some of them have different ways. Some questions might want you to enter a fraction, so just kind of pay attention to how they want you to enter the number. So 25% is our theoretical probability of rolling an odd number. We rolled 20%, so those are pretty close. So I will say here for question 8, pretty close, 5% difference. And as we're going to see later, if I had done more rolls, then I probably would have gotten a little bit closer. 20 rolls really isn't that many. So 20% was my empirical probability, 25% is my theoretical probability.